All right, so the last set of identities that we're going to talk about today are half-angle identities. So kind of the same sort of thought process for the double angles is that we need some formulas to come up with if we ever need to find the sine, cosine, tangent of any angles that we're going to cut in half for any reason, right? So here they are. Of course, we need a formula. These are going to look even a little bit more complicated than the other formulas. But again, we're just going to be familiar with them, be able to work with them, and of course, you'll have these given to you on quizzes and tests. The one thing I'll point out right away, so if I cut an angle in half, so the cosine of a half angle is going to come from this formula right here, 1 plus so the square root of 1 plus cosine of the original angle divided by 2. But if you'll also notice in the sine, cosine, and tangent versions, and if you notice tangent has 3 versions here, like cosine had 3 versions for the double angles. But in the sine, cosine, and one of the tangent versions, there's a plus or minus. It's because, again, we're square rooting, right? And it kind of stems from anytime you square root in an equation, what needs to happen. So whether those cosine, sine, or tangent values are positive or negative completely depends on what quadrant you're in, right? And it's all based on the quadrant for the half angle. So the angle cut in half, where that angle terminates, okay? All right, so let's just jump into it. Cosine of 15. Well, cosine of 15 is already a half angle, right? So we've got a cosine value here. We're going to use the cosine formula. That cosine formula says that the cosine of a half angle is equal to plus or minus the square root of 1 plus cosine of the original angle and then divided by 2. Now, a couple of things. The half angle is 15. Now, why is the half angle 15 instead of the original angle 15? Well, if you cut 15 in half, like this a over 2 wants us to, then you get 7.5. And 7.5 still is not a special angle in the unit circle that we can get the value of. But if 15 is the half angle, that means that the original angle is multiplied by 2, 30 degrees. So then that means that we're going to use 15 degrees here and 30 degrees here, which makes sense because we know what cosine of 30 degrees is from the unit circle. So I already know that 15 is the half angle and not a double angle for that reason. Okay, so we grab the half angle formula, and so the cosine of 15 degrees, positive or negative, right? Is this going to end up being positive or negative? Well, 15 degrees is going to terminate in quadrant 1. So since we're in quadrant 1, that means our cosine is going to be positive. So we're going to just eliminate the plus or minus and just keep this positive. So the cosine of 15 degrees is going to come from taking 1 plus cosine of 30 degrees, double it, over 2. Well, cosine of 30 is radical 3 over 2, all over 2. Now we're just working on the right side. Get a common denominator right here. We go 2 over 2. And this is the square root of 2 plus the square root of 3, all over 2. And then over 2. Then we can make this a fraction, flip it over and multiply. And so we get the square root of 2 plus the square root of 3 all over 4. Now, from here, we're just going to leave it. I know it looks weird, square root of 2 plus radical 3 over 4. But again, just trying to get used to these formulas, I think worrying about how to simplify that and all that kind of stuff is more than what we want to take on right now. So just leave it like that. Okay? There you go. Next one. Sine of 22.5 degrees. So again, obviously 22.5 is going to be the half angle. If you don't want to make that the angle and then take half of it and get 11.25 because it doesn't help us any. Right? So, but if you double 22.5, if you multiply this by 2, you get 45 degrees. So we'd rather use 45 degrees in our formula than 11.25. So the formula, which is the sine of the half angle, so sine of 22.5 is, and so we pour the formula. The formula says plus or minus the square root of 1 minus cosine of the original angle, so double it, all over 2. So yeah, interesting that sine still uses cosine. Okay, so to find sine of 22.5, well, first of all, 22.5 terminates in quadrant 1 because it's less than 90. So as far as plus or minus goes, it's going to be positive. Sine's going to be positive there. So 1 minus cosine of 45 is radical 2 over 2. And then we're off and running with simplifying. Make that 2 a fraction, flip it over. Well, actually, sorry, no, not yet. We want to simplify that numerator first. Common denominator for the 1, make that a 2 over 2. So we go 2 minus the square root of 2 all over 2. Then that's over 2. That's where we want to flip and multiply. And so we get the square root of 2 minus the square root of 2 all over 4. And again, we'll leave it like that in terms of simplifying it. Okay, so really just formula work and then trying to figure out how to work with the fractions and whatnot. So tangent of 22.5 is the same thing. 22.5 is going to be the half angle, which means that we got to double that to get to the original angle. So the original angle is going to be 45 degrees, which is a special for us. So the tangent formula, well, you have 3 options, right? So we can go plus or minus the square root of 1 minus the cosine of 45 degrees over 1 plus the cosine of 45 degrees. Okay? Now, tangent, this ends in quadrant 1, so tangent's going to be positive. So we just leave it here. So 1 minus radical 2 over 2 over 1 plus radical 2 over 2. Now get common denominator, so 2 over 2, 2 over 2. So we get the square root of 2 minus radical 2 over 2 over 2 plus radical 2 over 2. Then we're going to flip this guy and multiply it, and I'll show it down here. So 2 minus radical 2 over 2, all over 2, times 2 over 2 plus radical 2. Lots of 2's. Divide those 2's out, and you're left with the square root of 2 minus the square root of 2 over 2 plus the square root of 2. Again, keep in mind that those are 2 different factors. You can't divide any of that stuff out. They're not the same. Okay? So we just leave it like that. All right? All right. Okay, what about tangent of 75 degrees? Well, is 75 degrees a double angle or is it a half angle? Right? If you take half of 75 degrees, you're going to get 37.5 degrees, which is not a special. So that can't be a double angle. That must be a half angle. If you double 75, you get 150 degrees, which is a special angle in the unit circle. So 75 degrees must be a half angle, and we want to get to the original angle by multiplying it by 2. So we're going to use a half angle formula. So tangent of 75 degrees, okay? Well, I just used the first tangent formula. How about we use the second tangent formula now? Just to get used to the formulas. So I got to take sine of 150 degrees over 1 plus the cosine of 150 degrees. And so we get, let's see, sine of 150. 150 is 30 degrees less than 180, so it's going to be that bottom spoke in quadrant 2. bottom spoke makes sine positive 1/2 plus 1 plus negative radical 3 over 2. Now, need a common denominator down here, 2 over 2. 1/2 up here. We go 2 minus the square root of 3 all over 2. And then we're going to flip and multiply. So make this 2 over 2 minus radical 3. These 2's divide out, and we're left with 1 over 2 minus radical 3. And then we're done. Okay? All right. That's all there is to this thing. Just a little bit of fraction work. All right. Now, in terms of some little bit different problem types here, let's say that we know that the cosine of an angle is 2/3, right? We don't know the angle measure like we did in the first 4, and that's fine. We just know that the cosine of an angle is 2/3. And we want to go find the sine, cosine, tangent of the half angles, right? If I want to cut the angle in half, what happens to the value? Well, it's like our double angles from before. I'm going to move this 2 pi over here. It looks like it's lost, but just go with the formula and make sure that you have all the information that you need. So for sine of the half angle, to get that value, we've got to take plus or minus the square root of 1 plus cosine of the original angle all over 2. Okay, now, this says that A is in the quadrant between 3 pi over 2 and 2 pi, which is quadrant 4. Right? So since it's in quadrant 4, we've got to pay attention. That's where our... Now, the angle's in quadrant 4, which is fine, but we're supposed to, if you look back on the front page, we're supposed to base this off of where the half angle is, right? Not pi over 2 like your notes say, but the half angle, right? Well, that's great. Where is the half angle sitting? That means I got to divide the angle by 2. Well, if I divide the angle by 2 in this inequality, I've got to take half of these other guys as well. So take half of 3 pi over 2, you multiply a half into that, you get 3 pi over 4. And then take half of 2 pi, you get pi. So the half angle is actually in between 3 pi over 4 and pi, which is actually in quadrant 2. Okay? So we got to base our plus or minus off of quadrant 2. In quadrant 2, sine is positive, so for our sine of the half angle, we're going to keep the positive side of this radical and go 1 plus. Now, the cosine of A means we just use the cosine. The cosine of A we've been given. Cosine of A is 2/3. So we go 1 plus 2/3 all over 2. Then we go through and simplify. Make this a common denominator. Go 5/3 over 2. You got to make this 2 a fraction. Flip it over and multiply. And so now we get the square root of 5 over 4. And then because this is actually a decent looking fraction, I can go ahead and square root the numerator. If you square root 4, you get 2. And so the value of that is radical 5 over 2. Okay? All right. So for the cosine, for the half angle, cosine half angle, again, that formula, straight from the formula, is 1 plus cosine of A all over 2 inside the radical. In quadrant 2, cosine is going to be negative. So this plus or minus turns into negative. And again, it's because the half angle is in quadrant 2. So now we plug in 1 plus the cosine of A we've been given is 2/3 all over 2. Make this one have a common denominator. So now 3 plus 2 is 5. So we get 5 over 3. All over 2. Make this a fraction, flip it over and multiply. And so we get negative. And then 5 times 1 is 5. 3 times 2 is 6. And there we go with our value. Now, yes, I am now starting to see that I made a mistake in the first example, the sign of the half angle. Right here, 3 over 3 plus 2 over 3 should be 5 over 3. When I multiply 5 over 3 times 1/2, I should get 5 over 6. At which point, you can still split it up, split the radical up if you want, but you're not going to be able to square root either one of those. You could rationalize this if you want. If you bring the radical 6 up, you've got to multiply the 5 times 6 and get 30, and then leave the 6 in the denominator. But you don't have to. Okay, just if it bothers you enough. All right. All right. Next, we have, again, we want to find tangent of the half angle. We've only got cosine. So if you look through your 3 formulas for tangent of the half angle, you'll see that the first one there is the only one that uses just cosine. The other 2 uses a sine also, which we don't have. Yeah, we can go figure it out, but why would we do all that work if we don't need to? Right? So just use that first formula. Now, tangent in quadrant 2 is going to be negative. So this becomes negative square root of 1 minus, and cosine of A is 2/3, over 1 plus cosine of A, which is 2/3. And now we want to go through and reduce. Get a common denominator here and here, so that we can combine. 3 minus 2 is 1/3. 3 plus 2 is 5/3. Then we're going to flip over and multiply. The 3's will divide out, and we're left with 1 over 5 inside the radical. Well, we can make this minus the square root of 1 is 1, and then radical 5. And then again, if it bothers you enough, go ahead and rationalize that denominator. It's a bit easier to do this one than some of the others. So you get negative radical 5 over 5. Okay? And all this is just coming straight from the formula. All right? Next one. Again, we'll walk through together before we get to verifying a couple of identities, which we may or may not do. I'm not sure yet. So anyway, walk through one more with you, and then hopefully you're good to go with the homework. So cosine of the angle is negative 3 over 7. And so we want to find the half angle values. Now, we already know that we're going to have to figure out what quadrant the half angle's in. The angle itself is in quadrant 3. It's in between pi and 3 pi over 2. But I need the half angle, which means I need to take half of these angle measures, right? So that means that the half angle is in between pi over 2 and 3 pi over 4. And between pi over 2 and 3 pi over 4 puts us in quadrant 2. Okay? So where it seemed like we were in quadrant 3, the half angle is actually in quadrant 2. So we got to base our plus or minuses off of that. All right. So we've got the cosine of the angle. To find the sine of the half angle, we go plus or minus square root of 1 minus cosine of A all over 2. Well, in quadrant 2, sine is positive, so we can just drop the plus or minus. We go square root of 1 minus negative 3 over 7 all over 2. Now, 2 negatives make a positive, so I'm going to go ahead and make that. I'm going to make this 7 over 7 to get a common denominator. 7 plus 3 is 10, so we get 10 over 7 over 2, and all that is in the square root. Put 2 over 1, flip and multiply. Now you can cross simplify here. You're multiplying, not adding or subtracting. So you can divide the 2 and the 10 out and get 5 here. That leaves us with the square root of 5 over 7, at which point, again, you can separate and then rationalize or just leave it like that. I'm fine. Okay? Now, cosine of the half angle, let's work through that. It's plus or minus the square root of 1 plus the cosine of A all over 2. Now, cosine in quadrant 2 is going to be negative, so we got to keep this negative going here. So we get negative square root of 1 plus, and the cosine of A is negative 3 over 7 all over 2. Now, make this a common denominator. Can't read that. So now we go 7 minus 3, which is 4, over 7, and then over 2. Flip the 2 over and multiply. So you're multiplying by a half. You can cross reduce here, leaving us with just negative square root of 2 over 7. And we're done. All right. And then last but not least, tangent. Again, we've been given cosine of the angle. If we were given, we could go find sine if we want and use the other two formulas if you really wanted to. But there's a formula that just uses cosine already. So why make our lives any more complicated than we have to? Let's just go ahead and use cosine. Okay? All right, tangent in quadrant 2 is negative. So we got to keep this as a negative radical. We go 1 minus negative 3 over 7 all over 1 plus negative 3 over 7. If we get common denominators for our 1s, then we can combine our fractions. So 7 plus 3 is 10. 7 minus 3 is 4. We're going to flip this guy over and multiply. The 7's divide out. So you're left with negative radical 10 over 4, which, again, you can split up and make this negative radical 10 over 2 if you want, so that you don't have an irrational denominator. You can reduce the 10 over 4 to 5 over 2 if you want, and leave the square roots that way. Either way, we're good there. Okay? All right. And I'm going to skip these two verifying identity problems. They're not in your notes, and I don't think we're going to lose anything by not doing them. And I think we've got bigger things to worry about. So we'll end it there. Hopefully that's enough to get you through your homework. Give it a shot and bring your questions with you to class next time.